In this video, we're going to go through the practice questions for arithmetic and geometric sequences. And the first question says, what are the next two terms of this sequence? In this sequence, we are given these first 6 terms, and we're going to basically be asked for the next two, the 7th and the 8th terms. Since they don't tell us exactly what type of sequence this is, we have to determine, and we determine that from the data that we're given. So the first thing we want to look at is when we go from 1/2 to 1/4, how do we do that? Do we add to get that? Or to me, what seems easier is when I go from this 2 to this 4, it's just multiplying the 1/2 by another 1/2. And that will give me 1/4. So I multiplied by 1/2. Well, let's see if that works for the next term. When we go from 1/4 to 1/8, I'm looking for this pattern. Do I get that by taking the 1/4 and multiplying that by 1/2? That does equal 1/8, so that works. And we could do that by comparing from 1/8 to 1/16. We're going to multiply by 1/2. From 1/16 to 1/32, we would multiply by 1/2, and we would go on and on like that. So it makes sense then to go from 1/64 to our next term. We're going to multiply by 1/2, and that gives us 1/128. And we could almost go right there and look at our answer. That's going to be our next term, the first term, 1/128. That eliminates choice A, D, and E, but I have both B and C has that as the first choice, so I've got to figure out which choice it is. So we look at going from 1/128, multiplying that by 1/2, and we get 1/256. And that is going to make answer choice B the correct answer. Number 2, what is the 100th term in the sequence beginning with, and we have 4 terms. So we could look at doing something like we did in the first question if we were looking for, let's say, the 5th or 6th term, but we're looking for the 100th term. So we're going to have to make use of some of the formulas that we have figured out how to derive. In this case, first thing we want to do is find, how do we go? Is this we're adding a number to get to the next term, or are we multiplying? And if you can look, from going from -45 to -43, we added 2. Really doesn't look like something you would multiply to get to that. Let's just check ourselves. From -43 to -41, we're adding 2. And we can see we will add 2 to go here. So this is an arithmetic sequence with a common difference. We usually use D to represent that as 2. Now our first term that we started with, A sub 0, is -45. Now again, we're going to the 100th term. So to figure out that, A100 is equal to our very first term plus the common difference times 1 minus the value that we're looking for. We're going to multiply it times 99. And you can, if you forget this formula, what you can do is remind yourself by looking at the pattern. We're given our first value, and then we add the +2, just 1 times +2. To go from -45 to -41, we multiply 2 times that to get the -41, 2 times the common difference. When we put that in our calculator, we have a -45 plus 198, and we get 153, which is answer choice H. Number 3 says, if the first term of a geometric sequence, there's a key word, is 5, and the 6th term is 160, what is the common ratio? So this time we're looking for this common ratio. We know, since it tells us it's a geometric term, that we're multiplying, and we usually use ratio for multiplying. It tells us that the first term is 5, and the 6th term is 160. So we can make some equations out of this and figure out what is this common ratio. We know that the sixth term is equal to our first term times the common ratio raised to the 6 minus 1 power. And we can plug in what we know. We know that's 5. We don't know what r is. Raised to the 5th is equal to this 160, the sixth term. Let's solve for r by dividing through, and we get r to the 5th is 32. The 5th root of r, we'll take the 5th root of both sides, or you can think, what do you raise to the 5th power to get 32? And we know r is equal to 2 when you plug that in. And that is answer choice D. Number 4 says, if the fourth term of a geometric sequence is 27, so we know a to the 4th is equal to 27, and the 7th term is 1, so a to the 7th equals 1. What is the first term? Okay, there's a couple of things we can look at on this. So we're trying to go, we don't know what the first term is. And one thing we know from geometric sequence, we're multiplying something. We're going to have a common ratio we need to find. There's some things we can do here though. If you'll notice, when you go from a sub 7 to a sub 4, we're getting larger. So a sub 1 should be larger than 1. So we can eliminate answer choice F because that is 1/3. So that's one thing we can look at if we're just trying to look at our choices and figure out what it is. We also know that a sub 4 is 27, so a sub 1 has to be larger than 27. So we can eliminate choices G and H from that because a sub 1 is going to be larger. Okay, so that's just some simple smart guessing techniques that we can make use of. We don't know for sure if it's 81 or 729. Looking at how our values go from 1 to 27 between this, I'm going to lean more towards answer choice K, but let's prove that. And we're going to make use of some formulas and equations. So if you'll remember, we can write a sub 4 is equal to a sub 1 times r to the 3rd power. The power is 1 minus the value that we're looking for, but we know this to be 27. And we can also write that a sub 7 is also equal to a sub 1 r to the 6th, and that is equal to 1. So we now have two equations with two unknowns, but that means we can solve that. Let's go ahead and let's solve. We'll use this equation and solve for a sub 1. A sub 1 is equal to 1 over r to the 6th, just divided through by r to the 6th. Now I'm going to take this and plug it into this equation. So we have a sub 1 is equal to 1 over r to the 6th times r to the 3rd, and that is equal to 27. Let's simplify right here. That cancels out and leaves us 1 over r to the 3rd equals 27. We want to figure out what ultimately A1 is, but it's almost easier to find right here what our R value is. I'm going to rewrite this. I'm going to flip each term and have R to the 3rd equals 1 over 27. And now I know my R value, if I take the cube root of both sides, then I'm going to find that R is equal to 1/3. Now I can use either one of these equations. I'm just going to plug in and use this a to the 7th. We said a to the 7th is equal to 1. So 1 is equal to a sub 1, we don't know what it is and we're looking for that, times r, which is 1/3, we found that over here, raised to the 6th power. And let's simplify. And this is a to the 1st times 1 over 3 raised to the 6th power. That gives us 1 over 729. We're solving for r, so I'm going to multiply both sides by 729 to get rid of this. And I have A1 is equal to 729, and that is answer choice K. So a couple of different ways that we can use the formula, the equations to solve for that, or we can do some analysis by looking at the numbers that were given and then see what value would really make sense. Now let's take a look at question number 5. Given the arithmetic sequence, so we're going to be adding, and they give us the sequence here, these 4 values, what is the 15th term of the sequence? Okay, we have the first 4. We can find the common difference. We're going to be adding some value. So let's think about when we go from negative 12 to negative 7, what do we add to this? We're going to add a positive 5. Let's just check and make sure that works with our next values. From negative 7 to negative 2, yes, we added a positive 5. So it looks like D, our common difference, is a 5. Now we could continue on and find the 5th term to be 8, 13. We could keep adding 5, and that is definitely a way to do it because we're going to 15. We can probably do that in enough time, or we can plug in to our equation. And remember, we're looking for the 15th term. That is equal to the first term plus our common difference times 1 minus the value that we're looking for. So we'll have negative 12 plus, we found that common difference to be 5 times 14. And when we plug that into our calculator, we have negative 12 plus 70, which is equal to 58, which is answer choice D. Again, using our equation, or we can continue on adding 5, we would eventually get to 58.